Now, instead of observing the histogram of the image every time and try to find where the values are, what we can do is define the threshold in an automatic way. This would be better. So this is what I want to do basically in this video. So this is I'm gonna discuss something called basic global thresholding, and it uses an automatic way to find the threshold. Okay, so I want to discuss basic global thresholding, and the procedure is very simple, and it is known as this algorithm is just a special case of a more general algorithm that is called k-mean clustering, and it is used not only in image processing but also in machine learning. So you can classify pixels using the means. Okay, so in our case we are going to consider two means. This means that the k is going to be equal to 2. Okay, so let's say that I have an image, like some image that has the following histogram or distribution. Okay, so this is the intensity level and this is the frequency. So the first step in this algorithm is to set an initial value for t. Initial t, and let's call it tk, so this is tk, such that k is equal to 1 because it's the first threshold we set. So let's say that I pick up k here, tk here, this is t1, such that k is equal to 1, this is t1. So this divides the interval 0, 1 to two intervals. The first is 0 to t1 and the second is t1 to 1. Okay, so what I can do, the second step is to calculate the means. So I'm going to calculate two means. The first mean is of this region, the mean of this region, and the second is the mean of this region. Okay, so calculate mu1 and mu2 such that mu1, or the mean of the first interval, belongs to the interval 0 to t1, and the second mean belongs to the interval t1, 1. Okay, so by doing so I'm gonna get the mean in this interval, probably here, u1, and here what I'm gonna get is a mean that would be somewhere here. So the second step is to update, the third step rather is to update the threshold. Update tk. So this would be tk plus 1. Okay, so if k is equal to 1 here, then this k is going to be equal to 2. Okay, so update the threshold k, and we can say that the new threshold is going to be mu1 minus mu2 divided by 2. And this is just like saying get the second threshold or the new threshold between these two means. So this is the first mean and this is the second mean, and this is the center of this interval mu1 and mu2. This is gonna be my new threshold. Okay, and if you notice here, this second threshold is closer to this value than this first threshold, and if we keep iterating over and over and over, what we are going to get at the end is a mean that would converge to this position. Okay, this would be mu2 and this would be mu1. And the center of this mu1 in mu2 is here, so it's close to the valley. And the valley is, as I said in the previous video, is a good place to pick up a threshold. Now, why this happens, why this algorithm works, this is the main question that is interesting, and it's important to understand. The reason is because the mean has the property to converge to the position where the density is the highest or where the frequency is the highest. And if you know about Gaussian distribution, this would not be a secret for you. So this is the Gaussian distribution. Okay. So we have a standard deviation that takes about 35% of the surface. This is the standard deviation, and this is the mean. And the mean is always in the position where the distribution or the probability is the highest. Okay, so as a result, the two means I was considering here would converge to the peaks, to the position that is associated to the peaks of this bimodal distribution. Now, another thing that we should add to this algorithm is to set a condition to stop. Otherwise, we would iterate for infinity, right? So we need to stop when the threshold does not change significantly with iterations. So what we can say is, to update first this threshold into stop iterating if tk plus 1 minus tk is, it's not very big. The difference between two successive thresholds is not really big. This means that they are almost equal. Okay, so we can say that this difference must be smaller than t0, and t0, the smaller t0, the more accurate our threshold is. Okay, so this is how basic global thresholding works, and this is how we can identify our threshold automatically.